So as I mentioned before, what we have discovered here, or what we created there in that previous video, is what's called a logarithmic or log scale. So those tick marks on the x-axis are usually labeled with just the exponents of the power of 10. So instead of having 10 to the negative 2 and 10 to the negative 1, we relabel all these as negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and 7, and then we would note somewhere in our on when we label this axis, especially if we're doing like a three-dimensional or a two-dimensional x and y axis, we would label this as some note that it's a log scale. And of course, the answer key notes that as well. Here we've got that's the logarithmic scale with the powers of 10. So the issue with this is they look exactly the same, right? So the axes look like a standard axis with tick marks labeled from negative 1 to 0. However, it's quite different because the amount of units between these are powers of 10. So that means when I march from 0 to 1, I've actually gone 10 steps. So I went from 10 to the 0, being 1, to 10 to the 1, being 10. And then when I go from 1 to 2, that's another 10 steps, a product of 10 steps, right? So if I were to write out what this was, not in scientific notation, I know we already did this, but I guess it's worth doing again. We're going 0.01, 0.1, 1, 10, 100, 1,000, right? So it's a really weird kind of thing to wrap your mind around as you're looking at 1 really means 10, 2 really means 100. So you can see you should think about this more or less as exponential, this x-axis, because we're going by multiples of 10 in terms of units. So I kind of misspoke earlier. There's 10 units in between here. In between here, there's 90 units. In between here, there's 900 units. And then between the next one, 1,000 and 10,000, there's 9,000 units. So we could actually write an exponential function to model that if we wanted to. All right, so let's figure out what in the world is this logarithmic thing that we're talking about. So the exponents here used to label as tick marks of the preceding axis, these things, are logarithms, or more simply, we just say logs. That's the abbreviation of a logarithm. Since these are exponents of powers 10, the exponents are logs base 10, because each one came from the base of it was 10 raised to whatever that power is. We call those a common logarithm or common logs. Okay, so one of the things that we need to be careful with, this first example is a nice measurement of this, is understanding when we're talking about common logs, 10 to the 3 is the exponent to which 10 must be raised to obtain a result of 10 to the 3. So the common log of 10^3 is 3. How do we write that? So 1a, it looks like this. Log 10^3 equals 3. In America, anytime you see log, we understand that it has a base of 10. It looks like this. All right, and then for b here in our example, when we do common log of 10 to the negative 2, our notation would be we're evaluating, we're thinking of log of this. We get spit out that negative 2, the exponent. So we're supposed to determine the common logs of each of these examples below. So 10 to the negative 1, when we evaluate common log of that, it's just the exponent. For b, when we evaluate the common log of that, oh boy, you can't see this. Again, it's just the exponent because that's base 10. When we get to 1,000, that base is not a 10, but we know how to write 1,000 as a base 10. That would be 10 to the 3. So the common log of 10 to the 3 would be 3. 100,000? Ooh, what? So again, we know how to write that as a base of 10 with an exponent. We just count how many zeros are there. There's 4. This would be 10 to the 4th. So the common log of that, which really we would write it like this, it's coming on the next page when we define this notation, that would be 10 to the fourth. Ooh, tricky one, right? 0.001. Don't be tricked. You know how to write this in scientific notation. This is 1 times 10 to the negative 1, 2, 3, 4. We don't need the 1. It's just 10 to the negative 4. So the common log of that, again, we're going to look at this in a second, would be this. All right. So here comes the notation. Remember that a logarithm is an exponent. That's a key point. Put that in your brain forever. When we evaluate a logarithm of some number, we're wondering what is the exponent of that number. So the common log of x is an exponent y to which the base 10 must be raised to get result x. That is, so this gets a little confusing, I think, until you played with enough. That is, if we have the equation 10 to the y equals x, let me write this, 10 to the y equals x, y is the logarithm because it's the exponent of this equation. So we're going to use the log notation. This thing can be rewritten as log, common log, it has this base 10 of it, of whatever this x is equal to that exponent y. So I like their example here. When we take log base 10 of 10,000, that's really log base 10 of 10 to the fourth power. And since we know that the common log of a base 10 is equal to its exponent, that would be 4. So here's a quick example. 10 to the third, its exponent is 3. So the common log of 10 to the third is 3. All right, so let's flip that page. Let's do some nice examples of this. So key point here. When using logs base 10, the notation log 10 is shortened by dropping the 10 because it's common, huh? See where the name came from? So instead of writing log base 10 of 10 to the third, we really just write log 10 to the third, and everyone knows that this is a 10. Now, when I say everyone, I mean everyone that has been taught this, right? So from now on, you're going to be a part of that everyone. And then, so as your textbook notes, this is what you're going to encounter, and you're going to know that this base here matches this base. You're going to learn shortly that we can put any number we want here. Well, almost any number we want. There are some restrictions. Of course, this is equal to 3. All right, so let's determine the log of each of these. We kind of already did this, didn't we? That's what I was showing you. So and let me be more precise, determine the common log of each of these. So common log of 10 to the negative 1. This is understood that this is log base 10 of 10 raised to the negative 1. That's just that exponent, negative 1. Common log of 10 to the fourth, that's just 4. Common log of 1,000, that's tricky, right? No, it's not. Just rewrite this as 10 to the third. How did I know that? Well, I wrote this in scientific notation. There's 3 zeros, so I'm doing 10 to the third power. And then I know that this base here matches that. That's what common log is. This is equal to 3. All right, and then last two. Sorry, I do not have a great way to work through this textbook. That would be log of 100,000. Let's see, how many zeros? 1, 2, 3, 4, 5. That's 10 to the fifth. So this answer is 5. And then log of this crazy number, 0.00001. How many zeros here, or how many places would we need to move this? 1, 2, 3, 4. So we're going to multiply it by 1,000 in order to turn it into scientific notation, which means we would write this as log base 10 to the negative 3. Let me try again. We should do 10,000, which would be 10 to the negative 4, and our answer is negative